Hi, today we'll go over personal software process, also known as PSP. So in today's world, software pretty much controls everything that we do. It's there in businesses, it's used by the government, all the military systems are controlled by software, all of the factories are managed by software. So pretty much we cannot think of life without software. And along with that come a lot of responsibilities for creating a quality software. So the cost, the schedule, and as well as the quality of software has become a critical business concern because software is being used so heavily in all walks of our life. And typically you see big software projects usually fail, and there are reports that show that as the size of the project increases, the more they get into trouble in terms of the success rate. So this chart here shows that when the project size is smaller, when it's say less than $750,000 in cost, and when the team is smaller, so say the team size is 6, and then the length of the schedule for the project is shorter, say 6 months, reports show in the past the success rate with those kind of projects has been 55%. It is still at 55%, it's low, and you see that as the project size increases in terms of cost, in terms of team size and the scheduling, that success rate further falls. And you see that when we get to projects that are over $10 million with 500 plus people with long schedules running into 2 to 3 years, the success rate goes down, and it goes down to almost 0%. So the problem here is of a scale. As the software gets larger, the practices that are used do not scale up, and that's the reason these big software projects usually fail. And when I say fail, it could be in terms of meeting the deadlines, it could mean in terms of the quality of the software, it could mean in terms of the budget. So either the project goes over budget, or the project goes beyond the set schedule, or it ends up being a low quality software with a lot of bug fixing and patches to be done. So all of these are considered as failures. So why do these projects fail? Both large and small projects, they fail for the same reasons. The most common one is that the commitments made are often unrealistic. It's very hard to predict how much time it might take to build a certain software, and as that software gets larger and larger, it gets even harder, which means we are probably committing to something that's not realistic. The larger the project is, the less influence we have on it, because there are so many different parts, and all of these parts have to interact correctly with each other, and so the influence that we have on it goes down. The larger, so basically the bottom line is that the larger the projects, the harder it is to control and manage them, and it's hard to predict when whether one is on track or not. Now, there are very few developers who have a personal plan, who have a good personal plan, and whatever the size of the project is, finally it comes down to the individual developers who are writing code, who are developing the software, and the kind of personal process that they use. Without a good plan, it's hard to know what the status of the job is. So if I, as an individual developer, if I don't have a good plan for the piece of code or the piece of program that I'm developing, then it's hard for me to inform my higher-ups on what the job status is, and this has a trickling effect. Then the management doesn't understand what the job status is, and it's very hard for them to manage the projects and come up with other backup options, or have some kind of another process in place to make sure that the project is successful. So one of the big reasons projects fail is along with the size, it's basically coming down to those individual developers and the kind of process that they're following to handle their own personal tasks within the project. The second reason projects fail is because of quality. There are the quality problems in software. It gets worse as the project size increases. And again, the quality also comes down to the individual developers. If they do not manage quality of their piece of software, then the teams cannot manage quality of the entire system, and so on. So it again comes down to the individual developers following good quality practices. And to be effective, teams need leadership and coaching, and research shows that when teams are cohesive, motivated, and have committed team members, then they are able to do a good job and produce quality software. But for that, for an entire team to be effective, the individual developers on the team have to be effective and have a disciplined approach to programming. So these are the two big reasons why projects fail: the individual developers process and quality of the software. So there is a need for change, and it's even more important now because all our lives and businesses now depend on software. And then the softwares are typically getting larger, more complex, and there's a real concern with the safety critical software systems, and it's important that all of these software systems are built on predictable schedules with predictable budgets, and are safe to use. So there is a process called Team Software Process, TSP, that addresses this need. Basically, it guides teams to effectively manage themselves and stay committed on the job. But then, even before Team Software Process comes Personal Software Process. It's basically what it provides is the knowledge and skill to the individual developers to follow a disciplined approach to programming, and that way they're prepared to work on a TSP team. So the point that I'm trying to make here is we want to start with the individual developers and make sure that they have a disciplined approach to programming, so that they're able to perform well on a team, so that the team is effective, and then multiple such effective teams are able to produce quality software that's predictable with a high success rate and that completes on time and on budget. So that's where we are getting, and for that, Personal Software Process basically has certain principles, and following those principles, an individual developer can obtain or get into a systematic way of programming. So again, the PSP principles basically focus on quality, and it says that the quality of an entire software system is basically determined by the quality of the worst component that's in there. So a huge software system is made up of multiple components, so even if there's one component in there that's performing bad and is of low quality, then that determines the quality of the entire software system. The second thing is that the quality of the entire software is governed by the individuals who developed it. So if there's one worst component, then the individual who developed it is basically governing the quality of that software. So basically what this means is that the quality of the process that's used in order to develop that component is very important. And so the key here is to make sure that individual developers' skill, their commitment, and their personal process is disciplined, and there is a certain disciplined way in which they're developing, writing the code. To add to that, PSP principles also say that the way to achieve this disciplined approach is by measuring, tracking, and analyzing your work. And that's what we're going to try and do in this course, and through Personal Software Process, have individual developers, that is you, basically measure, track, and analyze your work so that you can learn from your previous work, and you can learn from the data that was obtained from that previous work. You can look at your performance, you can look at the variations in your performance, learn from it, incorporate any lessons learned into your personal practice. So basically the idea is you already know programming, that's the assumption. We're going with the assumption that you know programming, multiple programming languages, and you're already good at programming, say in Java for this course. And so now our next step is to basically for you to analyze what is your programming style. Where are you likely to introduce bugs? Where are you likely to, where are the issues in your programming practice? Identify them, and then from those lessons learned, basically try to change your process, and then again measure and track and see if your work is getting better. So basically that's the idea. So what PSP provides is it's a stable, mature process. This was described by Watt S. Humphrey of the Software Engineering Institute at Carnegie Mellon, and he's written multiple books on this. What the process says is that you start out by estimating and planning your work. So our goal now is going to be that you spend more time upfront in planning and design, rather than spending a lot of time on coding and fixing your code. So we're going to try and shift, if that's not what you've been doing, we want you to spend more time on planning and design, and do not start coding until you have a good design. And then the hope is that the amount of time you spend on coding and fixing your code will be much lower. So the process basically provides you with a way to estimate and plan your work, make sure you meet your commitments, and then we want to make sure you resist unreasonable commitment pressures. So this is where, and it's quite possible that the first few times you might make some unreasonable commitments, and when I say unreasonable commitment, this is in terms of time. If there is a certain module that needs to be developed, you initially estimate how much time do you think you will need in order to write it or develop it fully, completely. And if that, and then you track your time, and then compare and see how close your estimate was to the actual, and then learn from that. If it was not, if it was far away, then and why was it far away? Where did you take much more time than what you had planned for? So basically learn from that process, and then during the second round, the hope is that you're going to make a better estimate and a better estimate, and so on. So finally, you should reach a stage where you're not making any unreasonable commitments anymore. So here the goal is that you understand what your current performance is, what your current programming habits are, and then based on that you should be better equipped to improve your capability. So once you know where your strengths are and where your weaknesses are, you'll be better equipped to make improvements. So PSP provides this proven basis. So the Software Engineering Institute at Carnegie Mellon, they've done this for a number of years now with developers, and there's data that has shown that this process works, and it helps improve individual developers' personal process. So it's basically improving their productivity, the quality of the software, and the predictability of their work. So that's what PSP provides. So in the process, there is defined steps of how you go about. So given a specification to build a module, a software module, there are defined steps of how you would do it. there's some forms to keep track, to measure, basically to measure your performance in terms of time and defects. And then there are some standards like coding standards, defect type standards. So you use those standards in conjunction with this process. So the PSP is providing this measurement and analysis framework so that one can characterize and manage their personal work. It's a step-by-step defined procedure that can help you improve your performance. So here's how the flow looks. The PSP scripts are provided. That's basically the defined steps that I mentioned earlier. That's going to guide you through the different steps. So typically, like we've seen software lifecycle activities. So typically, given set of requirements, we start out with planning. That's the very first phase where you understand the requirements and then a plan on how the software will be developed for it. The next activity is design. So once the planning is done, requirements are understood, you design the software. Then code, compile, test, and then do a post-mortem, an analysis of what went right and what went wrong. So these are the typical steps, and then finally we have a finished product. Now our goal here is spend more time on planning and design, and so that we can effectively code, compile, and test. So typically we've seen that when developers don't plan and design properly, they end up spending double the time in coding, compiling, and fixing the bugs and testing, and again recompiling and fixing. So we want to minimize that amount of time, and as you go through this, the hope is that when you compile, there should be no bugs. It should be a bug-free software that right away succeeds in all of the test cases, and you should have the finished product. So basically, the scripts will guide these different software development activities. So there is the process flow is the same as is done typically. And then in addition to that, there are logs. So the logs will basically are those forms that I mentioned earlier. So the logs could be there's a time log to track how much time you're spending on each phase. And when I say each phase, I mean how much time you spend in planning, how much time did you spend in design. And this is important because we want to know where you're spending most of your time, and then later we're going to see where are most of the defects introduced, and where were the defects injected into the code or into the software system. So we know during which phase the injection happened, so that then you can look back at your data and see, did you spend enough time in that phase, and if you did not, maybe that's where you need to pay more attention. Now the other kind of logs are, there's a defect log. So we keep track of all of the defects, when the defect was injected and when in which phase it was injected. Was it during planning phase, was it during design phase, or was it during coding phase? And then when was it finally removed, and what type of defect was it? And the reason we do this is you track defects so that you can, again, as an individual, to understand what your programming habit is and what is the type of defect that you typically introduce. Is it you try to use a variable that was never initialized, so maybe there is some so you're not thinking through at the beginning of the coding what are the different data structures and how are they initialized, or is it about the array bounds are not getting checked properly and you're getting your errors are because of that. Then you have to more carefully think of your data structures, edge cases, so and you pay more attention to that when you're coding. So basically we look at these different defect types to understand where you're introducing most of the defects, so that you can make it better in the subsequent iterations. So scripts is the step-by-step guidance, and then logs are basically the forms using which you track your data that you can then analyze later. And then there is a project summary, so that's where we're actually doing the analysis of all the data collected as you develop this software module, and then you use that information in your future projects. So this is the PSP process flow, and you keep doing this with all of the programming activities that you're doing, and use the analysis from this last phase in your next coding activity, and so on. Now the idea is not to use this forever. I mean, you do this a few times, and within a few iterations of doing this, you should get into a more disciplined way of programming, and then after that you don't need to do the measuring and tracking anymore. It's just you do it until you get into a disciplined habit of programming and producing quality software. So that's the idea, and during this course we'll go through multiple programming activities so that you can practice this PSP process and measure and analyze, and then incorporate your findings into your next iteration. So PSP, traditionally the way it's done at the Software Engineering Institute is of Carnegie Mellon is that there are 6 upward compatible steps. So they do it in 6 steps, and in each step the programmer writes one or more module size programs. The idea is to keep it small and write a module size program that's manageable in each of those steps. So again, here the focus is not learning programming. We are assuming that you already know programming, but there could be some flaws in your style of programming. That's what we want to identify. So basically you gather and analyze data on your work in each of those steps, and then use those results to improve your performance. So the 6 steps are basically PSP 0 is the baseline process. One starts with that. So that's where the idea over there with PSP 0 is to understand your current process. Don't have to do anything different, just follow the way, just program or code the way you would normally do, and then do some tracking of time and defects using the defect type standard that's available, and so you have that first round of data to analyze. And then once you have that, so basically the next step is where you start estimating. So in PSP 0 there's no estimations, we're just establishing the baseline, but in PSP 1 you again do everything. You still do the time recording and defect recording, but in addition to that, in the planning phase, now you're going to estimate time and defects. You're going to estimate for a given problem description how much time are you likely to take to complete that task, and how many defects are you likely to introduce in developing that module. And then from there, again you collect data, analyze it, and then move on into PSP 2. So these are basically the steps, the multiple iterations. In PSP 2 we add another level. So along with doing the estimations and tracking your data, we're also going to do reviews, design reviews and code reviews. So that's what you see over here, design and code reviews, because now we want to add quality aspect. So we want to make sure that as you're writing the program, you're also making sure you're writing a quality program. And I said that our focus is to spend more time upfront in the planning and design. So when you do the design, you also do a design review to make sure there's a checklist for the design review that one could use, and make sure all of the different important aspects are covered, all the requirements are covered in the design. Then you do the coding, and you do a code review even before you get into testing. So the code review can be done at a personal level, or it could be done it's always recommended that you first do it yourself, desk check your code, and then have someone else do a review for you. And again, data shows that when these kind of reviews are done, the number of errors and bugs found later on in testing is reduced drastically. A lot can be found in these at static time using these reviews. So PSP 0 is establishing a baseline. In PSP 1 we're going to start doing some estimations. And then in PSP2, we add quality to it. We add some quality aspects to it. There's also between PSP0 and PSP1, there's a 0.1. So basically, this is step 1, step 2, step 3, step 4, step 5, and step 6. So 2, 4, and 6 are additional. So if one is on a time constraint, then they would just do the 1, 3, and 5. If not, doing all 6 steps would be the ideal thing. In the 0.1, we add a few more things like coding standards, and if those coding standards have been followed or not. After estimations are done, then there's what's called task planning and schedule planning. So in this, there's a way to, in the planning phase, you break up the module that needs to be developed, you break it up into multiple tasks, and then assign an order to those tasks, the order in which they need to be completed, and then based on that do a planning. So then you estimate time for each task, and then look at the schedule that you have and how much time you have. Based on that, come up with a plan. So that's more detailed estimation. So PSP1 does a basic estimation where you just say what's the amount of time that you might need to complete a module, and how many defects are you likely to produce in it. But then this is more detailed estimation that's done in the task planning and schedule planning of PSP 1.1. Then in PSP2, the reviews are done. In PSP 2.1, further some design templates are used to make sure that a good design is produced. Once a developer goes through these 6 steps, at the end of those 6 steps, the hope is that they would have achieved a disciplined approach to programming, and are hence now ready to participate on a team software process, which is basically the next step that's used in building effective teams. So there the requirement is that the individual developers on the team first must have a personal software process, and then they can build an effective team. So basically, PSP0, PSP1, and 2 are the ones that are done. I mean, especially when you're in a time constraint, we could do that, and that's what we will be doing in this course. There'll be a first activity to measure and come up with a performance baseline for each of you. Then the next step would be to start making estimations, and then the third step would be to practice, to introduce some quality practices into your process. Now the phase order in which this is performed, it pretty much looks like a waterfall process, though it isn't exactly that. So the idea is you cannot test code before it's compiled. It doesn't make sense. And then you cannot compile code before it's written. You cannot write code before there is a design for it, and then you cannot design when you don't have your planning and the requirements. So basically the idea is to start at the bottom at this planning phase, and then go up into design, code, compile, and test. So that's why I said it looks like a waterfall process. But then, having said that, it doesn't necessarily have to be a waterfall, and I'll show you that it can be an iterative process. So basically, when you're following PSP, the idea is analyze your requirements, plan, design, code, compile, test, and then do a postmortem. The postmortem is very important, so that's where you're analyzing all of the data that you've collected, so you can incorporate it into incorporate any of the findings in your next iteration. Now a cyclic process can be followed, so basically it can be iterative as well. So when there are larger programs, it's harder to understand larger programs and requirements. So in that case, what one could do is take the requirements, do the planning and design up front. Those will be the first 2 steps, and then as part of the design, the entire software system can be broken up into multiple modules. So in this case, it's broken up into 2 modules, module A and module B. Then one could go through module A first, code it, compile, and test it completely. Then go to the second module, code it, compile, and test it completely. And then when all of the modules have been completed, then go through a postmortem process. So that's a way in which larger projects could be better understood and managed using an iterative approach. So in this case, just the code, compile, and test part are following that linear waterfall style model, but everything else is iterative. It could also be further broken down in a different way. Say the project is really large, where even the design, it's hard to design up front, then maybe you just do the planning at the beginning. Only the planning is done so that the one could decide on the different modules, and then for each module you design, code, compile, and test. And then once the first module is complete, then you move on to the second one, design, code, compile, and test it, and so on. So that's another iterative approach where only the planning is done first and everything else then is broken up into multiple iterations. So whatever works best for the given requirements and given problem specification, the developer has to choose between these process flows. So typically the PSP process script, it looks like this, wherein there's and this can be customized, but the one that's followed by or used by the Software Engineering Institute at CMU, it's typically a 1 or 2 pages long that describes what the entry criteria is that you should have, and then what are the different steps and the description for each of those steps, and then an exit criteria, what is it that you do at the end of this process. So there is a detailed process script that's provided that the programmers could blindly follow. So basically the activities in this are include planning, then the development, and then postmortem. So that's the kind of script that's provided. And in each of those steps you will see that there are in the planning it says you obtain and go through the requirement statement and then estimate the amount of development time needed. So that you will see in steps or tasks like enter the planned data into the summary form. So as you're doing this, you're also entering data into the forms. At the beginning of each phase, you're recording in your time log at what time you started and what time did you stop working on that particular phase and move on into the next phase, and so on. So there's detailed steps in there for that. And then in the postmortem, typically what's done is everything is summarized, the total amount of time spent in each phase, and then the total amount, the total time spent on the entire module, and then the number of defects found and injected in each phase, and then the total number of defects in the entire module. So those are the kind of things that are recorded during the entire process. And basically, again, we're doing this. We're going through this just to establish and get into that. To force yourself to get into a disciplined habit, and once it becomes a habit, after you've done it a few times, it becomes a habit. Then you don't have to do it anymore, and it's not done anymore. I mean, you don't see people in the industry tracking their time at this level for each phase. It's you do it at this learning in this learning stage, so that once this disciplined approach becomes a habit, then you're done, and then you're able to do better estimates and make proper commitments that can be met. So there's going to be a number of activities, and there's going to be future videos that will further explain it. But the purpose of this video was to give you an overview of personal software process and what it means. Okay, thank you.